Hello, hello, hello. All right, guys, we are going to be looking at another couple of standards today. I know we are getting towards that EOC, so please make sure you're watching these videos. I know we go through them quickly, but if you have questions or concerns, just send me an email. So go ahead and pause the video and read about Christy and Darren and see what you think. So Christy and Darren set goals for improving their recorded times for the mile. Which statement best describes these goals? Christy, complete each new run in 5 fewer seconds than the previous recorded run. Darren, complete each new run in 5% less time than the previous recorded run. Okay, so what we can do is Christy's is actually linear. So every time she wants to take 5 seconds off her mile, where Darren's is a percentage. So Christy's is linear while Darren's is an exponential function because there's a percentage difference. All right. So which situation best describes the graph? Go ahead and pause the video, take a look at which of these situations is best going to describe that graph. So if you look, our initial value is $500. So we know we're going to be looking at B or C. Okay. So 8% increase or 8% decrease? Well, since this is going in that positive direction up, I know that that graph should be increasing. Oops. All right. Which equation represents a linear function? Remember, a linear function is in the form of y equals mx plus b. So go ahead and pause real quick. Check out these equations below. Which one is going to represent a linear function? That would be A. It's actually in the form of y equals mx plus b. So anything that looks like this, not linear. Anything with a square we know is quadratic. If it has 1 over y, definitely not linear. It's the same thing if we reworked this, we would end up with y equals 1 over x, same thing. Definitely not where we're going. All right, guys. So Rachel and Mark were given information. All right. We're given the information below about bacteria growth in a petri dish. Rachel wants to model with a linear function. Mark wants to use an exponential function. Which one's a better choice? So I would say that an exponential function would be much better because if you look, this is going up by 60, then it's going up by, if we were to calculate this would be 2070, so this would be going up by 70. This would be going up by 90. Then we'd be going up by another 60 plus 50 would be 130. So as you can tell, there's not a linear relationship because that slope between them is not the same. But an exponential function, now that makes a little bit more sense. All right. Moving right along here. So the point A on the graph represents the distance and time that Kat traveled on her trip. Which of the following represents her average speed? So in order to find average speed, we are talking about slope. If we were to draw a line here, we could actually calculate her rise over run, which would give us the slope of that line. Very, very, very nice job. Okay. So, continuing right along, I know we are whizzing through these. We have a lot to cover in this last week before our EOC. So, the development budget, C, for a computer company is described by the equation C equals 50,000 T plus 10,000. Where T is the number of years since the company's creation. Which statement is true. So the true statement here, okay, is each year development expenditure increased by $50,000. So each year, right here, we're increasing by $50,000 because that $50,000 is times T, and T is our time. All right, looking at the one below, Lanquina, I don't know how to say that, trains for the long jump each week. She writes this function to model the relationship between the number of weeks, W, she trains and the distance in inches she can jump. What does the slope of the function represent? So take a look at that. What does that slope represent? If you said the number of inches that she jumped the number of inches Laquina's jump distance increased per week of training, you would be correct. Okay, we are about halfway through. We've got a couple more standards to cover here. So let's take a look at this next standard. This is all about constructing linear and exponential equations. So it says, what is the equation of the function represented by this table of values? So we definitely can tell that this is not going to be linear. Not linear at all. But what we need to figure out is, well, what is happening here? So we start by looking at our initial value. That initial value is 3. So when you're writing an exponential function, your initial value is this first number times whatever the rate, whatever that exponential growth is. And here you can see from 3 to 15, so when I go from 0 to 1, I'm increasing by a factor of 5. So if I were to plug this 1 in, so if I plug this 1 in here, our initial value is 3, 5 to the first is 5, y equals 3 times 5, which is 15. Same thing here. If I plug this 2 in, y equals our initial value of 3 times 5 squared. 5 squared is 25, and 3 times 25 is 75. So C is my correct exponential function. All right, so moving on to number 3, if x and y are defined as indicated by the accompanying table, which equation correctly represents the relationship? So in order to figure out the relationship, you need to figure out your rate of change. So I would start there. What is your rate of change? What's your intercept going to be? Well, our rate of change, remember, is y, so our change in y over our change in x. So my change in y goes from 1 to 3, which is 2. My change in x goes from 2 to 3, which is 1. So my slope is 2. Okay. So that means if I go back, right, if I keep going back, I need to find my y-intercept. So if I go back here, so think about this table going back, where x is 1, 1 minus 2, because we're going backwards, is negative 1. Then I want to go to 0. So I'm going back another 1. So I'm going to take away 2 more. So negative 3 would be my intercept. There you have it. Okay, so now that we talked about initial value in that last problem, go ahead and check out number 4. What do you think the correct equation is? If you said C, you're correct. Our initial value is 150, right? So I need to figure out what factor this is. What is this being exponentially multiplied by? Well, my exponent is 1, so t changed by 1, right? So now I need to figure out, okay, well, 450 divided by 150. So 450 divided by 150. That's 3. So my factor that it's increasing by is 3. Alrighty guys, last one for this standard. A population that initially has 20 birds approximately doubles every 10 years. Which graph shows the population growth? Keyword here, they said doubles every 10 years, which means this is not linear. The other hint they gave you is that we had initially 20 birds. So it can't be A, because initially 20 birds would be here and here. Well, if we're talking about doubles, that's an increase. So your correct answer choice would be C. All right, guys, we've got just a couple more problems here. Hang tight. These ones you guys have become really, really awesome at. So go ahead and read this problem. What is the equation? What is the function that shows the total number of miles Jay's car will have been driven in more days? If you said D, that's correct. Because each day he drives a total of 45 miles, right? He already has 27,000 miles on that car. So 27,000 is our initial value. The 45 is being multiplied every day that he's driving. So your correct answer is D. Alrighty, oops. Alright, so let's go ahead and take a look here. We've got a sequence is created from the function k of n equals 3n plus 1, where n represents the position of the term in the sequence. The sequence does not begin at 0, which thus represents the first 5 terms. So our first term does not begin at 0, so we're going to start with our first term at 1. So we're going to start at k equals 1. So if we plug 1 in, we rewrite this, we get 3 plus 1, which is 4. If we plug our second term in, we have 6 plus 1, which is 7. If I plug that third term in, I have 9 plus 1, which is 10. And so from there we can see our correct answer would be B. All right, guys, so please make sure that you check out all of these standards in USA Test Prep. I can't wait to see you guys soon. Have a great day.